The creation of our database system has completed. As you can tell, the status is now available. If you notice, we're on the details page of this database system. But if we go back one level up to all our database systems, you will notice that we now see both our original as well as our clone in our compartment. So now that we clone our original database system, let's work on our clone. We were on this detail page before, and now, just like before when we provisioned a new database system, now let's work on our clone. Let us connect to our clone. You may notice for this clone, just like the original, it is one database. You notice it's the same name. If you go into the nodes, there's the unique name of that node and the public IP address. Like before, we would like to use this public IP address to connect to our database system. I made a mention in a previous demo that there may be times, depending on the version of the tools you use, that it may see your key having an old format. So I want to show you an example. Since I'm in Windows, I brought up my PuTTY key generator, and I am going to go into Files, and I'm going to load my private key. This is the private key that was generated as part of the creation of the clone. When I loaded that key, this notice popped up. You notice it successfully imported the key, but it is in the old format, as noted here. And that's okay. That's the purpose of why we're doing this. So now that I loaded it and it sees that's an old format, it says, would you like to make it a new format and save it in that new format? And technically, it says its own format, it's the new format. I say okay, and it's going to ask me, where would you like to put it? So I would wish to save that private key. Now that I wish to do that, it asks, do I wish to save it without a passphrase? Think of a passphrase as a password for your key. Again, for simplicity, I would say no, but if I am doing this for a project with my company, I would consider yes, because it provides another level of security. For now, I would say, are you sure you want to save it without it? Yes, I am sure I do not. So it asks me where to put it. Now that I've done that, let's use a utility, in my case, PuTTY, to connect to the database system. Launching PuTTY, I provided the IP address of the database I wish to connect to, and that would be this. After providing the IP address, I go into SSH, I go into auth, and I browse to locate the private key that I just saved under the new format. Once I do that, I click open. Here, again, would be the message, the alert. This is a key that has not been cached before, so it's not certain that it is safe. You would know. So in this case, I know it is, so I would accept for it to connect. And it's asking who I will log in as. And remember, may only log in as user OPC. So now I am in user OPC. But remember, my objective is to really be, for example, user Oracle, so I can really be accessing the database. So let us sudo to user Oracle. In order for me to connect as user Oracle, I must switch user. But remember, I am user OPC, so I need to perform the command as if I'm running it as user root, which is whom I cannot connect to as. So in order to do that, I must sudo. Sudo allows me to do that. It really allows me to run a command if I am user root. So I sudo, I switch user, and the user I wish to switch to is user Oracle. I am now user Oracle. That would be my home directory. And as you can see, I am now user Oracle. If I type in SQL+, for example, as user Oracle, I may log in to the database. I wish to log in as user sys. It prompts me for the password. Now remember, this is the password that I provided to the clone database system. So when we were creating the clone database system, in turn it created the database, we needed to provide the SSH, a new one, which we did, and a new password for the administrator of the database. So let me enter in that password. For the purpose of security, I clear my page, so this is on top, and I'm showing my connection as connecting as user sys with the password, and as you can tell, I am now in the database of the clone database system. Congratulations, you now not only clone your database, you change the key as well as the password to log into the database. Once we've done that, we use the private key to connect to the database, and here you see you have successfully connected to the database. This concludes our demo. Oracle Cloud Infrastructure, OCI database maintenance. In this lesson, you will learn about some of the features of maintaining your database and your database system. Upgrading a database system. Now, before we start, I want to make a distinction between your database and your database system. Your database is really a collection of data that's stored on your server, your computer. Think of your table spaces, think of all your tables in your table space and the data that you provide your users access to. Your database system is, think of it as the environment that the RDBMS is running on. It allows access to the database. So you're really interacting with the system, the server, that will provide you access to interact with your database and to manipulate the database itself. Before we start, you want to make sure that you have access to the compartments in the cloud infrastructure where your database system resides. So make sure you address all the identity access management policies to ensure that access. Database system upgrades involve some downtime, even if you're in a rack database system environment. So make sure that you plan and schedule your updates accordingly. Though the update process will itself disable and re-enable any automatic backups, Oracle recommends that you disable the automatic backups before executing the upgrade. It's encouraged that you back up your database before applying any updates to your system. Patch the database system before updating a database for the database system with grid infrastructure. Before you apply any updates, run the pre-check operations. Ensure all the servers and the database instances are all up and running. Ensure the directory /u01 has about 15 gigabytes of free space. For a single instance database environment, we suggest you provision a data guard standby and update it first to maintain your system availability. In a two-node rack environment, updates are done in a rolling fashion to maintain system availability. As a reminder, if you are going to update your grid infrastructure on a system with that grid infrastructure ASM storage management, you must update your database system. In addition, also remember, updating your database system does not update the operating system. So it's a really good idea after you launch your database system, after the upgrade, that you apply any operating system security updates. You can upgrade your database. For example, you can upgrade your database from a previous version. Upgrading database requires downtime. There's no concept of rolling upgrades. This is true even for a 2.0 rack database. If you're upgrading the database to version 19c, make sure you're on Oracle version 7 of Linux. The process of upgrading your database to version 19c is similar to the process of updating a database. You want to make sure you run the pre-check prior to the update process. Upgrading through the console is not available for databases in the a data guard configuration mode. And after upgrading, you cannot use an automatic update that was taken prior to the upgrade to restore a database. So you need to make sure you perform another backup. Always be aware of what the new version of upgrading a database will bring. The new version may have more or less columns in your system tables, as well as views, new or modified system packages or procedures, as well as possible new or changed database types, user roles, as well as privileges. So always be aware of what are the actual features of the upgrade. Changing the shape of a database system. After you provision your virtual machine database system, you may want to change the shape at any time to adapt to the changes in the performance need of your workloads. If you wish to migrate your database system from an Intel-based shape to an AMD, you will need to change the shape of your database system. However, changing the shape does not impact the amount of storage available to your database system, though the new shape can have different memory and network bandwidth characteristics, and you might also need to reapply any customizations to those changes if you implement any customizational changes from your previous shape, change of shape, or implementation of a shape. Database encryption key. For your virtual machine database system, you can choose to encrypt the database using your own encryption key, and we refer to those as custom managed or customer managed keys, or let Oracle manage the encryption key for you. We give you an option of both, so it would be your choice for Oracle managed or customer managed keys. You can enable customer managed keys when you create your virtual machine database system. We strongly encourage you to rotate your keys to maintain security compliances. Think of cases of personnel changes, or if you wish to disable access of a database from everyone. You can switch from an Oracle managed key to a customer managed key on an existing database. Note when switching to a customer managed key, a database, the container, and its pluggable databases must be open, and all table spaces of the database must be in read-write mode. You can go from an Oracle managed key to a customer managed key, but you cannot go from a customer managed key to an Oracle managed key. That is not supported. In this lesson, we learn about some of the features of maintaining your database and your database system.
Hello everyone. In this and the following lessons, we are going to discuss about one of the flagship database service in OCI database service offering. It is called Oracle Autonomous Database. So let's learn a bit more about this database service and what makes it so different from other database services. When considering the different Oracle database services initially available with OCI database service, they would include VM or bare metal based database systems, or it could be the database in dedicated Exadata infrastructure in public cloud or cloud at customer. They were semi-managed database services, that is, there is a shared responsibility between Oracle and the customer. Many of the actions were triggered by the customer, like patching up the database and the database system, upgrading of the database, manual scaling the configuration as the workload demand rises, manually tuning the application queries running the database, handling database failure scenarios, handling security, applying security patches, configuring high availability, etc. So these are the actions what you would be performing as a customer on the different database service we discussed. Some of the actions may require downtime, which would impact business, and they also tend to add some management overhead, though not equivalent to an on-premise database deployment and management. But it would be definitely be more productive for you if these overheads are entirely overcome by having a system that self-manages on behalf of you. This is where we introduce you to a fully managed database service called Autonomous Database Service. It eliminates the complex overhead of managing a database while being a highly available, secured, scalable database service with a very high performance capability that makes it an ideal choice for your production database workloads. The core design of Autonomous Database is such that the entire database stack is automated. It encompasses the Oracle Enterprise Database that has evolved with many years of engineering efforts to enrich it with maximum automation into the database functionality. It is built upon the best database infrastructure, that is Oracle Exadata, to further boost your database performance by many folds. Coupled with this is a built-in machine learning capabilities that monitors and automates several key areas, including workload optimization, query performance, security, anomaly detection, and failure handling, with complete automation of the data center operations. And overall, your entire database service is hosted in a highly protected and highly available Oracle Cloud Infrastructure region. Autonomous Database is a fully managed database service. It automates several areas associated with your database deployment. It automates provisioning, configures database based on the type of workload. It can self-tune, automate patching and upgrade without downtime, automatically secures the database from external or internal attacks, and it provides instant elasticity to scale your database on demand. Now let's try to dig a bit more into the several capabilities. Autonomous Database in itself is a self-managing database service. Looking at the provisioning aspect, you can provision an autonomous database in a matter of 2 to 3 minutes. This enables you to achieve your rapid database deployment target timelines for your production workloads. And the database is provisioned in a multi-tenant architecture in a scale-out design comprising of Oracle Real Application Cluster and high availability Exadata infrastructure in Oracle Cloud Infrastructure. Autonomous Database is highly secure platform that protects your database from external threats as well as internal threats. All the necessary security patches are applied online on priority. None of these database admins in OCI can check into your database, as these actions are restricted by database vault. And the biggest concern around your data security, this is addressed by mandatory data encryption rule, which encrypts your data whether at rest or in motion. On the various management aspect of the database, it automates all infrastructure and database maintenance activities like applying of storage patches or system patches or upgrades. It can tune your database configuration. It monitors the database and can automate operations for diagnosis and resolution. Autonomous database also keeps your database safe. It can automatically detect and recover during physical corruptions or infrastructure failures. It removes manual intervention to perform this recovery in the event of a failure or disaster by automating the entire repair process, thus avoiding any chances of human errors and delays. Oracle Autonomous Database is built on the lines of Oracle Maximum Availability Architecture to provide maximum availability and avoid any downtime. It automates backup of your entire database to recover from any unwarranted errors. It also allows you to automate extreme availability of your database service by giving you an option to create standby or backup copies of your primary database to which you can switch over or fail over in the event of any natural disaster occurring in the OCI region. Scaling of a database system is usually needed to meet the changing workload requirements. This can be dynamic or maybe inferred from a capacity planning exercise, and usually scaling operation requires a downtime, but in case of autonomous database, it provides instant elasticity. That is, you can increase your compute capacity when the demand rises and scale down when the demand falls. And this is done instantly without incurring any downtime of your database. At times, it might not be feasible to decide what is the exact compute size to scale your database. Then you can enable autoscale to scale up the compute to 3 times of the provision compute to meet the workload demands instantly without you manually scaling up the compute. And when the demand falls, it will automatically scale down the compute. In addition to performing scaling operation on the compute, you can also perform scaling operation on the autonomous database storage which is allocated. Autonomous database can automatically optimize your query performance. It automatically creates indexes, partitions, it automates SQL plan management, automates statistics gathering, it creates resource plans and associates it with services to control concurrency and parallelism so that your application can connect using those predefined database service connection string based on the concurrency and parallelism needs. Autonomous database supports different workload types and has a broader support ecosystem. It is integrated with majority of Oracle Cloud Infrastructure services like data integration, Oracle Analytics Cloud, OCI Object Storage, and developer tools like SQL Developer and Apex, Oracle Developer Cloud Service, and other third-party data integration tools, BI tools, and application in Oracle Cloud Infrastructure or in on-premises. To summarize, Oracle Autonomous Database enables you to relieve you of the several database manageability overhead, providing automation across different aspects, be it provisioning, security, availability, performance, maintenance, etc., so that you can be more productive by focusing on your business and application development. It is protected from downtime. It is safe, secure, delivers high performance. It is designed based on maximum availability architecture to ensure high availability, the machine learning based automation it gives you, and many other such factors that makes it a complete package database service that is ideal for your mission critical database. I hope this briefing on autonomous database service gives you some basic understanding of what an autonomous database is and what makes it so different. Thanks for watching. Hello everyone. Welcome to the next lesson on autonomous database. Here we are going to learn about the different workload types that are supported with the autonomous database and also understand some of the key differentiation with respect to handling of the different workload types. Briefly, we'll touch upon some of the key features with respect to performance management when handling these workload types. Typically, an organization will have two kinds of workload that could be transactional or an analytical workload. Each type of workload differs by the way data is stored, retrieved, and accordingly the performance handling mechanism changes for both. Oracle Autonomous Database is a fully managed database service that is tuned and optimized to handle the different workload types. Autonomous database primarily supports 4 different workload types. The first of the type is Autonomous Data Warehouse, abbreviated as ADW, and is designed for analytical workloads. Specifically, it is meant for building your data warehouse, data marts, data lakes, and machine learning workload use cases. The second in the supported workload type is Autonomous Transaction Processing or ATP. It is optimized for transaction processing workload or mixed workloads. Autonomous Transaction Processing database is very pertinent for high performance complex transaction processing system use cases that may also serve to process analytical workloads in the same database. That's why Autonomous Transaction Processing supports mixed workload as well. The next two workload types supported by Autonomous Database are focused on the developer community. The third workload supported type is Autonomous JSON Database or AJD and is designed for developing JSON-centric applications. Autonomous JSON Database natively stores your JSON documents, and you can use NoSQL style APIs to store and retrieve JSON data and build applications that use JSON documents collection. You can also store data other than the JSON collection with a limit of 20 GB. Autonomous JSON Database is based on Autonomous Transaction Processing Database. Hence, when there is a need to store more data than the 20 GB limit, you can promote your Autonomous JSON Database to ATP. The fourth and the last supported workload type is Oracle Apex for application development or the Apex service. It is designed for Apex developers to quickly spin off an Apex service instance and rapidly build and deploy low-code Apex application. It provides browser-based, easy-to-use development environment to load data, manage database objects, and build your application with the rich built-in features which is provided with Apex. Let's take a look into the workload optimization capabilities built into Autonomous Database for the two different workload types. ADW or Autonomous Database optimizes the execution of complex analytical SQLs, whereas Autonomous Transaction Processing or ATP optimizes the transactional queries execution to deliver faster response time and higher throughput. The data storage for each type of workload plays a key role in delivering high performance. Analytical workloads benefit by storing data in columnar format, where the interest is only on few columns and not the entire table. ADW, which is optimized for analytical workload, stores those data in columnar format and compressed. This makes data storage more efficient and it enables faster retrieval of only smaller chunks of required columns data to perform the operation and return to end user. And also the database in-memory columnar format uses Exadata flash cache to accelerate the analytical operation. Whereas in ATP, the data is stored in a row format since the transactions are interested on fewer number of rows. In order to retrieve data faster and accurately in ADW, data summaries are created. This takes advantage of the Exadata feature, which creates storage indexes automatically on the disk and in flash to make your scans more accurate by pruning out unnecessary scans. Whereas in ATP, since it is a transactional processing database, data is retrieved faster with the creation of indexes. ATP supports the creation of indexes manually, or you can take advantage of the automatic indexing feature provided with Autonomous Database. Since the data volume in case of data warehouse is very huge, having the entire warehouse data in memory to process them is not feasible. Hence, the majority of memory in Autonomous Data Warehouse is used for improving the performance of the joins and aggregation. Whereas in case of ATP, since the data is selective in nature, the working set data volume is not so high as in case of ADW. Hence, majority of the memory in ATP is used for caching the data, as this avoids the disk I/O, and this makes a significant jump in your query response time. The object statistics is crucial input for Oracle Optimizer to generate an optimal execution plan for your SQL. Hence, it is required that the database has the most recent up-to-date statistics for the tables and indexes in order to render better query response time. In ADW, the statistics are gathered automatically as part of the bulk load operation, and histograms are automatically generated along with that. Whereas in case of ATP, these statistics are updated during the DML operation itself. Let's now briefly discuss about some of the automated capabilities that significantly contributes towards better performance in each of the workload types. Autonomous Database controls concurrency and prioritization by defining predefined services in the database, which are otherwise called consumer groups. These consumer groups are used for establishing database connections by your application. Each of these consumer groups is assigned different CPU and IO shares as defined by the the resource management tools which a user connecting to the database can use from the database resources. This share allocation depends on the type of autonomous database workload type. As you can see in the table below, there are 5 different consumer groups. ATP and AJD provides all the 5 different consumer groups, while ADW provides high, medium, and low consumer groups. TP Urgent has the highest priority for critical transaction processing, and it allows you to manually set the parallelism in your application query. High consumer group can use maximum resources, but they provide least concurrency, and the queries will run in parallel. Medium consumer group has lesser resources, but they provide higher concurrency compared to the high consumer group. Low consumer group provides highest concurrency and least resources, so queries cannot run in parallel. They are serialized. The priority goes from TP Urgent to low consumer group. The plans shares column depict how much share does one consumer group has over the other. For example, high consumer group can use up to 2 times more resources than medium consumer group and 4 times more resources than low consumer group. The red asterisk indicates what will be the concurrency value depending upon the compute configuration you have chosen during provisioning with autoscale disabled. That is, if you have chosen OCPU based model or eCPU based model. When you enable autoscale with either OCPU based or eCPU based model, then multiply the number by 3 for the consumer group high and medium. Next in the list is the idle time limits. Autonomous database terminates idle sessions that are holding resources for more than 5 minutes in order to make resources available to active sessions that are waiting for the resources. Autonomous database allows you to configure automatic termination of runaway SQL statements that may be running for a longer time. You can set the runtime runaway rules for each of the consumer group to limit the query runtime seconds and amount of IO beyond which the session will get terminated. As mentioned earlier, autonomous database automates creation of indexes and partitions on the tables to make data retrieval faster. It automates gathering of object statistics either during bulk load or during DML operations depending upon the type of workload. It can perform automatic SQL plan management and create SQL tuning sets automatically to detect SQL that have regressed or are consuming significant system resources, and then it can enforce best plans to improve their performance without the need for you to intervene and perform this task manually. All these characteristics make the database an autonomous service on its own. To wrap up on this lesson, we see autonomous database is designed to support the different workload types. It optimizes the configuration to support the different workload types, whether it is transactional workload or analytical workload. Besides that, the resource manager rules enables you to efficient use of the system resources. Depending upon the processing needs of your workload, it allows you to choose the consumer group that provides the necessary concurrency and parallelism as needed for the operation. In short, it has taken a holistic bottom-up approach to provide you a fully managed database system that can manage the different workloads autonomously without you engaging entirely in designing, provisioning, administering, and managing a database system. I believe this gave you some more details on the autonomous database capability in managing the different workload types. Hope this was helpful to you. Thank you. Welcome everyone. In this video, you'll learn about the different deployment options for an autonomous database. Till now, we have understood all the different capabilities built into autonomous database and the benefits it can provide to an organization. Coming to the provisioning and using of autonomous database, we need to decide what would be our choice of deployment to meet continuous business needs. There could be several factors that can influence this decision. For example, whether it should be accessed publicly or limited access, whether you need to have higher control and security of your database service, whether the data that will reside in the autonomous database can be stored in external data center or should not leave your data center, database environments like test, dev, production, and even the cost concern. So all these criteria are looked into when choosing the deployment option. With the Oracle Autonomous Database, you get multiple deployment choices that can suitably address these concerns. The first type of deployment choice would be in public cloud. Here you get 2 options to choose from. One is a shared infrastructure where your database service would share the infrastructure with other customer. This is the simplest deployment and can quickly get you started with your application development. The second option is dedicated infrastructure. You choose the shape of your Exadata infrastructure and it is entirely owned by you, not shared with other customer. You can perform more customization and control your deployment to meet the enterprise business needs. In both these options, the data resides in Oracle data center and has to travel over the network to and fro between the customer data center and Oracle data center. There are scenarios where organization has to comply with data sovereignty law of the country, or your organization policy has to store and process data locally to your data center, or you're concerned about network latency that may occur due to application being deployed locally and database residing in a far off data center. These concerns can be easily overcome by using a second method of deployment, that is Oracle Autonomous Database on Exadata Cloud Customer. In this deployment, the entire Exadata database service hardware runs behind your own data center firewall. This addresses the network latency concern while keeping you fully compliant with the data sovereignty regulations. The third type of deployment choice is called dedicated region cloud customer. This is nothing but your Oracle Cloud Infrastructure public cloud in on-premise data center. This is nothing but your Oracle Cloud Infrastructure public cloud in your on-premises data center. This brings a complete portfolio of OCI public services into your data center, and that includes your autonomous database services as well. Here we'll run through some basic explanation about each type of deployment. Starting with shared infrastructure, this is the simplest and fastest deployment service with elastic provisioning. Oracle provisions and manages Exadata infrastructure and the associated software and the periodic objects. The Exadata infrastructure is shared with other customers, but there is no over provisioning. It ensures highest degree of isolation with Vault integration and does not compromise on security or performance. You do not have to worry about the maintenance of the database system. All patches are automatically applied on the database system in a rolling fashion without bringing down the system. You can only focus on your application development activity. There is a bare minimum commitment with just 1 hour usage, 1 OCPUs and 1 TB of storage, and you can scale up online as the demand grows. Alternatively, you can enable auto scaling for OCPUs and storage. Since this is a shared infrastructure, you cannot set any schedule for the various maintenance activity. Like you cannot push the patch apply date in order to implement a new release. You will be given advance notification about the upcoming maintenance activity so that it gives you ample time to plan your change releases. Autonomous database in dedicated infrastructure is your private database in Oracle Cloud Infrastructure public cloud. It provides more control on your deployment and allows you more governance that aligns with your organization need. It runs inside a hardware enforced virtual cloud network, entirely isolating your deployment from other customers. You can manually scale or auto scale storage and OCPUs just like shared infrastructure. You can host both data warehouse or transaction processing workloads. It requires you to first subscribe to dedicated Exadata infrastructure in OCI, and that will be entirely reserved for your autonomous database deployment. Next is autonomous database in Exadata Cloud Customer. This is similar to autonomous database in dedicated infrastructure, but instead of deployment in public cloud, Exadata database service Cloud Customer is hosted in your own data center. This provides Exadata on Gen 2 hardware with elastic provisioning capability. This is a chosen platform when the database deployment choice is governed by different policies like data sovereignty law, GDPR, industry regulation, data residency requirement, or could be a technical challenge in moving the legacy application to cloud close to your database in public cloud. This differs by network configuration from autonomous database in dedicated infrastructure, along with the backup destination. So you may choose a backup to be taken locally with NFS storage or OCI public cloud object storage, or you can also use zero data loss recovery appliance as the destination. So you may choose any of the deployment option that best fits your business needs. As a summary, Oracle Cloud Infrastructure infrastructure gives you the flexibility to choose your autonomous database deployment based on the user's profile, the kind of control needed depending on the criticality of the application that is going to use the service. You can also choose the deployment option to comply with the data sovereignty laws of the country. I hope you now have a fair idea of which deployment option to choose when you're going for a new deployment of autonomous database in Oracle Cloud Infrastructure. Thanks for watching. Welcome everyone. In this section of the video, we'll expand our understanding on the different self-driving capabilities of an autonomous database. Oracle Database self-driving capability automates all the infrastructure and database management activity of the database. This differs from the traditional database management where it involves a lot of human labor and it is more error-prone. Oracle Autonomous Database hides all these complexities from you, the maintenance and management involved in a traditional database, by providing you a fully managed database platform for your users so that you can shift your focus more onto application development rather than managing a database. Let's now learn about some of the individual attributes under self-driving. Auto-provisioning, as the name implies, will quickly provision an autonomous database for you. You do not have to configure any hardware or install any software in order to provision a database. Based on the compute and storage requirement you specify as inputs, it will quickly provision a pluggable database in a rack-enabled multi-tenant database. It ensures high availability of your database by provisioning it in a rack database on accelerated hardware, which itself is highly fault tolerant. This also allows elasticity by adding more nodes to the cluster and also helps in keeping your database always available during maintenance. It automatically makes the decision as to on which node of the rack cluster should the autonomous database reside. It is enabled in few nodes of the cluster, and the database may be open on one or more nodes. Auto provisioning thus instantly provisions a fully managed Oracle database in a platform optimized for your Oracle database in just few minutes. It automatically sets the underlying platform to keep your database always available, freeing you from all the traditional database management overheads. Hope it was helpful. Thanks for watching. Welcome everyone. In this lesson, I'll be discussing autonomous database provisioning in shared infrastructure in OCI public cloud. To start up with some emphasis on key capabilities of an autonomous database in shared infrastructure, this is the simplest and fastest deployment of Oracle database in Oracle Cloud Infrastructure. We just need to provide few inputs like what should be the database name, display name, number of OCPUs, storage size, version, and the kind of network access, choice of encryption, and your database is ready for use within few minutes. Autonomous database adopts the Oracle maximum availability architecture, best practices to keep your database always available. Always on encryption of your data is pre-configured, and the data, whether at rest or in motion, is always encrypted. The database ensures highest availability with an SLA of 99.95% uptime. Access to the database is secured using TCP/IP protocol, and the mode of access can be controlled when choosing the network access. Applications can connect to the database using credential file available specific to your database. You can also enable auto-scaling of OCPUs and storage to meet your dynamic workload demands. There is a level of shared responsibility in this model. Oracle is responsible for provisioning and managing the database infrastructure components and automates the entire data center operation with applied machine learning that continuously monitors the components for any faults and performs quick issue resolution. You, as a database owner, are responsible for provisioning the database, controlling the access to be granted to the end users, manage your application data and application users. Let's now move on to understand some more details. During provisioning, there are a few crucial inputs that you must note. Selecting the type of network accessibility, that is how access to your autonomous database can be controlled. There are three different options as you can see in this image, but we'll discuss more about it in the next part of the video. Choosing your type of encryption for your TD master key. Here you choose whether this master key encryption should be managed by Oracle or you should use your own key for encrypting TD master key. You get two options to choose from. That is choosing between encryption using Oracle managed key or encryption using custom managed keys. Third is choosing the patch level. There are two different patch levels, early and regular. Early patch level will automatically apply the patch 1 week before the actual public release date, and regular will apply the patch automatically once it is released publicly. Usually, if you have a test instance, you can choose the patch levels as early so that you can fully validate your application for any incompatibilities and have them fixed by raising a service request. This can be done before the patch is applied into the production environment. Now let's look deeper into the network access control options available with autonomous database and shared infrastructure. First, secure access from anywhere. This means your autonomous database can be securely accessed over the internet by any client which has secured credential file, and this requires a mutual TLS authentication. The second is secure access from allowed IPs and VCNs only. In this network configuration, though the database has a public endpoint, but it cannot be accessed by all clients over the internet. This limits access only to whitelisted IPs as defined in the access control list or only to those VCNs for which the security roles has been configured. Third type is the private endpoint access. This is recommended when you are provisioning critical databases in the cloud. You deploy a database in the private subnet of your VCN that creates a private endpoint for your database. To allow access to this database, you need to configure the required security rules and network security groups. Here, let's discuss about the client connection, the modes and types with autonomous database and shared infrastructure. Client connection in this deployment are established over TCPs, and these connections are secured using TLS 1.2 protocols, which ensures that the data is encrypted throughout the transit to and fro between the database and the clients. Oracle database uses a self-signed certificate for authentication, which is included as part of the ZIP credential file. Oracle Autonomous Database supports two different types of authentication, MTLS and TLS, and it depends upon the type of network access you have chosen. If you have chosen secure access from anywhere, then it enforces MTLS-based authentication. If you choose secure access from allowed IPs and VCNs, then you can use both MTLS and TLS or just MTLS. You can restrict authentication to use MTLS method only by keeping the checkbox required mutual TLS authentication ticked in the console, which is the default setting, as we saw in the previous image. It's the same behavior if you choose private endpoint access only, where you choose both MTLS and TLS or just MTLS by keeping the default settings. The supported connection drivers include JDBC thin driver, JDBC OCI, OCI, and ODBC. For MTLS-based connection, you must download the credential file and set the path in your wallet file before you can establish session with your autonomous database. For TLS-based authentication, you do not have to use the wallet file, but as a criteria, you must first either have the access control list or a private endpoint configured for your database. However, whether you choose MTLS or TLS-based connection in autonomous database, both modes provide encrypted communication between the clients and autonomous database. This is a graphical representation for secure access from everywhere network access control, and a customer can establish connection to autonomous database either from their data center or elsewhere using the wallet file downloaded from your autonomous database details page. The data is encrypted before it reaches TCPs and decrypted at the other end once it reaches the database, and vice versa. versa. This is a graphical representation for second type network access, secure access from allowed IPs and VCNs only. The client connection can either be from the customer data center or from any of the Oracle Cloud Infrastructure Compute or DVCs. Depending upon that, you have to configure an access control list or configure security list to allow connections to autonomous database. And this is the representation for that type of network access, private endpoint access only. Here, your autonomous database is deployed in private subnet of your VCN. Clients in customer data center must establish IPsec VCN or fast connect to have a secure connection to the autonomous database in OCI private subnet. And customers who already have application running in OCI private VCN, they can establish connection to the autonomous database via a service gateway with needful security rules added to the security list. To wrap up in this lesson, Oracle Autonomous Database and Shared Infrastructure is the fastest provisioning database service in Oracle Cloud Infrastructure. It is a highly secure database platform offering you different network access control to choose from depending upon the network position of your client that needs to establish connection. With online scaling operation and elasticity, it can meet your changing workload needs on the fly without affecting the availability of your database. Hope this gives an idea about provisioning an autonomous database and shared infrastructure. Thanks for watching.